Happy holidays, YouTube. It is a little past Christmas, and I want to talk a little bit about DuckDB versus Polars. I recently did a test, yet another test, where I generated 1 terabyte of Parquet files in S3, and then I used DuckDB, Daft, and Polars to go ahead and read the entire 1 terabyte, the entire thing. And I just wanted to talk about how DuckDB was able to do it fine, how Polars crashed out of memory like the new pandas that it is, and then Daft got it done but a little bit slower. Okay, so I want to take a second to talk here about what happens in real life in production when we are working on, say, a lakehouse or a large data sets in the cloud. Typically we have a lakehouse, whether it's Delta Lake, maybe Iceberg, maybe it could just be a bunch of Parquet files sitting in cloud storage somewhere. Maybe we have hundreds of terabytes, a couple terabytes, a lot of data. And typically what happens with modern query tools is that we go ahead, whether it's DuckDB, Polar, Spark, anything. These query engines have become smart and we point them at the data set, a large data set. Most people think, hey, if it's big, I just have to use Spark, I have no choice. And of course, we all know that the entire data set is never read. You know, we may have 150 columns in a data set and we may need 4 or 5 columns. Of course, there may be filters applied, etc., partitioning, clustering going on, data skipping happens, selective data read happens, etc. Things like Parquet, things like these new query engines are smart enough not to read the entire data set. It just typically doesn't happen in real life. We have large data sets, but typically when we're querying data sets in production, for whatever reason, we're typically not scanning every single row and reading every single row, every single column. That's just not how it works in real life. But to kind of shush the naysayers of the last time I did this test with about 650 gigabytes, people were complaining that, hey, you're not actually reading 650 gigabytes. It's like, well, no crap. That just doesn't happen in the real world. That's not how it works. But just to shut them up, I went ahead and generated a 1 terabyte data set with like 4 or 5 columns. I came up with a SQL query to use every single column that required every single column, every single row, and went ahead and ran that on a 64 gigabyte machine, 1 terabyte of data in S3 with DuckDB, and it went ahead and it processed the whole thing, basically proving that, yes, you can process massive data sets with these new tools. Let's go through it. Okay, so we'll start with generating the data set. If you go over to this GitHub repo, this is what I used. I wrote it in Rust, and basically it will generate 1 terabyte of data in S3. As you can see here in the screenshot, 1 terabyte of data, a little over 9,000 Parquet files in S3. There they are sitting there. If you're curious what the schema looked like, it was pretty straightforward. There's a transaction ID, a date time, a customer ID, an order quantity, an order amount. So 5 columns there, pretty straightforward. And I went ahead and I spun up a Linode instance with 64 gigabytes of RAM and 16 CPU cores. So obviously 64 gigabytes of RAM is way smaller than 1 terabyte. And we wanted to see, can DuckDB process this? Can Polars process this data? Of course, if you want to follow along, you can go ahead and clone that repo, but I just used UV, that wonderful Python tool, to go ahead and make a new project. And I just added DuckDB, PyArrow, Boto3, and Polars at the end. One thing of note, you probably want to use no hup when you're running on an instance, especially Linux instance, because this stuff you don't know how long it's going to take to process. You don't want your terminal or SSH session to time out. One thing I wanted to note about DuckDB that makes it awesome and that made it able to do this, process 1 terabyte, every single gigabyte of that terabyte it processed on a 64 gigabyte machine, mostly because of 2 reasons. One, DuckDB allows you to spill to disk, which is awesome. And then another thing that allowed DuckDB to do this and Polars not to do this was that you can set memory limits in DuckDB. You can say, here's my, in my case, I set the memory limit to like 50 gigabytes, even though it's a 64 gigabyte machine. Said, hey, you can't use any more than this. If you need to, you can spill to disk. And that allows it to work on larger than memory data sets. DuckDB comes with a streaming query engine, so it's able to fill up, use that memory you want, but not explode it. You cannot set a limit on Polars and say, hey, don't go over this. It simply doesn't work. They don't have that kind of setting. There is some like thread safety stuff you can kind of set with Polars. I played around. It just wouldn't work in Polars. Polars works great for smaller data sets, even what some would consider big data sets, 50 gigabytes, yes. But when it comes to actually large data sets, in this case, 1 terabyte. Say we had a couple 100 terabyte data set lakehouse, we actually needed to do some big queries that actually read 1 terabyte. Polars can't do it. It doesn't allow you to say, hey, I've got a 64 gigabyte machine, you got to max out at 50 and use no more than that. Even using the streaming lazy execution in Polars, it blew up and could not complete this no matter what I tried. Just didn't have the ability to say, hey, stop. And if you don't believe, you can go ahead and Google around with that on the internet. You'll find plenty of GitHub issues where other people are saying the exact same thing with large Parquet datasets, and their GitHub issues have been closed and the world moves on. Anyways, let's look at this extremely simple DuckDB code. Some of the first things I'm doing here, besides the obvious DuckDB, setting the database to memory, and I go ahead and set the memory limit of 50 gigabytes. Remember, we got 64 available. I probably could have bumped it up. If I just cut it off at 50 and also set a temp directory saying go ahead and spill things here if you need. And then, of course, here is my simple SQL query to use those 5 columns. I went ahead and grouped by the date time, and then go ahead and count the number of transactions, count the number of customers, sum the order amount, sum the order quantity by day, order that, and then go ahead and write that out to a CSV file. Pretty straightforward, and this query requires the entire 1 terabyte data set to be read in memory, streaming in nature, of course. I want to point out one thing about how easy this is. I want to say from a data architecture level, when we're thinking about Spark, Databricks, Snowflake, BigQuery, Redshift, all these big, large architectures that are complicated, we didn't have to install Java. There's no jars, no backflips. There's no tuning, deployments. This is just DuckDB. This is as simple as a pip install, man. That's it. That's your architecture. And I also want to say, this was done on a single node, 64 gigabytes in size, Linux machine. There's no clusters here. We don't need any of that complexity. So what's amazing here is the simplicity. The simplicity of the code, the simplicity of the architecture. We live in an age where everything has to be complicated. These tools are powerful, they're fast, they can work on large data sets, as I'll show you here, and it's just super easy. Anyone can do it. I was curious how much memory was being used, so I went ahead and ran this free -h on my Linux machine, that 64 gigabyte machine. And you could see it floating around 48 gigabytes during usage. That's how much memory is being used on this instance. So it didn't quite float up to the 50. I probably could have bumped it up maybe to 60 and had it float to 55. But DuckDB was going ahead, it filled up about 48 and sat around there. It was using that memory. And I sat around and waited, and of course I put some timing in that script, and this was the results. It took about 19 minutes, a little under 20 minutes for DuckDB to read that entire terabyte data set, every single piece of it, and go ahead and write out that CSV file with the results. Here's a CSV file. It worked like a charm, and it only took about a little under 20 minutes. And again, I tried this with Polars. It simply would not work. Even with its lazy execution, it just simply wouldn't do it at scale. It would just eventually run out of memory for whatever reason. And this is a common issue if you go on the internet, look around, GitHub, Hacker News, etc. Other people have, this problem when they're working on very large data sets. If you call 1 terabyte large, and it is large, and you're talking about single node tools, not distributed tools, say like Spark, that's not large, but for things like DuckDB, Polars, etc., that's a large data set. And Polars definitely has some issues there. A lot of people have issues. They pretty much get closed. People blame it on the operating system, etc. But at the end of the day, DuckDB can do it, DAF can do it. So, I don't know why the Polars people don't fix this. I have no idea. They just won't. Anyway, let me know what you think. DuckDB whops Polars. I used to be a Polars lover. Turns out I love DuckDB more because it actually works.